Let's do this question. Find x. So clearly it's a find the number type data sufficiency question. So we have to find a unique numerical value of x. All right. So let's look at statement 1. It's given that x cube is equal to minus 27. So clearly from this statement, we can find that x is equal to minus 3, right? There is no ambiguity. We are able to find a unique numerical solution. What about statement 2? Statement 2 says that x square is equal to 9. Therefore, x can be equal to 3 or minus 3, right? So because 3 square also is 9, minus 3 square also is 9. So statement 2 alone is not sufficient, right? And statement 1 alone is sufficient. So the correct answer to this question is option A. Let's do this question. Is x an even number? Alright, now the two statements given is 4x is even and 3x is even. Pause the video, give it a try, and then let's do it together. And these are the 5 options. Alright, statement 1 alone is sufficient, but statement 2 alone is not sufficient. That's answer option A. If 2 alone is sufficient, but 1 alone is not sufficient, that's B. If you need both, that's C. If each can solve this question on its own, that's D. And if you cannot solve even after using both the given statements, that's option E. So, alright, so pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now, this is a classic case of an assumption trap. Alright, now what's the assumption trap over here? It's not given that x is an integer, right? It's not given that x is an integer. Now, let's go ahead and solve this. Statement 1 says 4x is even. That's not sufficient, right? That's not sufficient. Why is that so? If I take the value of x as 1, I get 4x as 4. So this is even. And over here, 1 is not even, right? So I'm getting an answer no over here. Now, if I take x as 2, 4x is 8. This is still even. And in this case, 2 is even. So I'm getting yes over here. So sometimes I'm getting yes. Sometimes I'm getting no. There is no definite yes or no. Therefore, statement 1 alone is clearly not sufficient. What about statement 2? It says that 3x is even. Now, can you conclude because 3x is even that x is even? You cannot do that, right? Why is that so? It's not given that x is an integer. Now, let me take the value of x as 4 by 3. So, what would be 3x? That would be 3 into 4 by 3, which is equal to 4. And this is even. But in this case, 4 by 3 is not even, right? So I'm getting a no over here. Now, if I take x as say 6, so that would be 3 into 6, that's 18. And in this case, this is even, and over here you're getting x as even. So you're getting a yes over here. So you're getting sometimes no and sometimes yes. Therefore, statement 2 alone is also not sufficient. Let me make some space over here. Now, let's try statement 1 and 2 together. So I'm making some space over here as well. Alright. Now, this is statement 1, that's 4x is even, and statement 2 is 3x is even. Alright. Now, let me subtract 4x minus 3x. So that would be even minus even, right? And that has to be even, right? We have seen that even minus even is even. So 4x minus 3x has to be even. And 4x minus 3x is equal to x. Therefore, x has to be even, and hence, using both the statements together, we are able to arrive at the conclusion that definitely, yes, x has to be even. Therefore, the correct answer to this question is option C. Let's do this question. Is x an even number? Alright, now, again, statement 1 says 9x is even. That is not sufficient, right? You could have x as 2. In this case, 9x is 18, which is even, and therefore x is even. So you're getting a yes over here. But if you take x as 1 by 9 or 2 by 9, in this case, 2 by 9 into 9 is equal to 2. So this is even, but 2 by 9 is not even. So you're getting a no over here. So statement 1 alone is clearly not sufficient. Similarly, statement 2 alone is also not sufficient. Alright, so option A and option B are ruled out. Now let's try statement 1 and 2 together. Now we know that 9x is even and we know 7x is even. Now even minus even has to be even. Therefore 9x minus 7x, which is equal to 2x, has to be even. Alright, now let's subtract 2x from 7x. So 7x again is even, 2x is also even. So 7x minus 2x, that's equal to 5x, and 5x also has to be even. Alright, now let's subtract 2x from 5x. We get 5x minus 2x is equal to 3x. That has to be even. And let's subtract 2x from 3x. We get 3x minus 2x is equal to x, which has to be even. Therefore, yes, using both the statements together, we are able to arrive at the definite yes for this question. Therefore, the correct answer to this question is option C. Let's do this question. Is n by 24 an integer? The two statements given are 7n by 24 is an integer. Statement 2 is 3n by 24 is an integer. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now to start with, let's simplify the question. Now let's take n by 24 as x. Then the question is x an integer? Alright, now statement 1 says 7 into n by 24 is an integer. Now if n by 24 is x, then statement 1 says 7x is an integer. Alright, now 7x is an integer. This is not enough information to conclude whether x is an integer or not, right? You could have x as 1 by 7. In this case, 7x would be 1, which is an integer, but 1 by 7 is not an integer, right? So you're getting a no over here. Now if x is equal to 2, 7 into 2 is also an integer, right? In that case, x is equal to 2, which is an integer. So we are having a yes over here. So this is clearly not enough information. So statement 1 alone is not sufficient. Alright, what about statement 2 alone? We have 3x is an integer, right? Because n by 24 is x. So 3x is an integer. Now if 3x is an integer, can we conclude whether x is an integer or not? We can't, right? If we take x as 1 by 3, it's a clear no. If we take x as 2, it's a clear yes. So again, we have no sometimes and we have yes sometimes. Therefore, statement 2 alone is also not sufficient, right? Alright, so let's try statement 1 and 2 together. Now, over here, we know that 7x is an integer, right? And we know that 3x is an integer. Now, if I combine statement 1 and 2 together and subtract them, so 7x minus 3x, which is equal to 4x. Now this also has to be an integer. Why is that so? You take any two integers and if you subtract them, you will get another integer. For example, 3 minus 7 again gives you an integer, or 7 minus 3 gives you an integer, or 10 minus 21, this again gives you an integer. So integer minus integer has to be an integer. Therefore 4x is an integer. Now we know 3x is an integer and we know 4x is an integer. Now let's subtract these two. We get 4x minus 3x, that's x, and x is an integer. Therefore, the correct answer to this question is option C. That is, using both the statements together, we are able to arrive at the answer. That is, x is an integer. Alright, let's do this question. If x and y are positive integers, is x to the power 2y plus 2 plus x square into y to the power 2x odd? So the given expression is x to the power 2y plus 2 plus x square into y to the power 2x. And we need to find whether this is odd. So it's a yes or no question. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, over here, you can see that in both these two terms, x square is there. So let me take that out. So I can rewrite this as x square into x to the power 2y plus y to the power 2x. Now the first statement over here given is x is even, right? Now if x is even, x square will be even, right? And x to the power 2y also will be even, because you take any even number and you raise it with a positive integer, that will give you another even number. All right, so this is even, and what about y to the power 2x? So if y is odd, so that would be 3 to the power an even number, say 3 to the power 4, and if y is even, that would be 4 to the power 4. In this case, this is odd, and in this case, this is even, right? And remember, over here the power is always positive because it's mentioned that it's a positive integer. So no fractions are coming into place. Why is that so? If it was not given and say you're raising 3 to the power minus 4, then this would be 1 by 3 to the power 4, and this is not even an integer. Alright, so this case is not possible because it is mentioned that x and y are positive integers. Alright, so as per the first statement, when x is even, you have even, x square is even, into x to the power 2y is even, plus y to the power 2x is either even or odd. So you have even or odd. So definitely this product will be even, right? Even into anything is even. So this statement alone is sufficient. Alright, what about statement 2? It's given that y is odd. If y is odd, we don't know anything about x, right? So over here we have even or odd for x, and x to the power 2y also will be even or odd, but y is odd, so odd to any power will always be odd. So as per statement 2 alone, this is even or odd into even or odd plus odd. Alright, is this sufficient? If x is even, this statement becomes even into even plus odd. This is even, so this is sufficient. If x is odd, this becomes odd into odd plus odd, right? And odd plus odd is always even, right? Therefore this statement alone is also sufficient, right? So therefore statement 2 alone is also sufficient, and hence the correct answer is option D, that is statement 1 alone is sufficient and statement 2 alone is sufficient. Let's do this question. Bob plotted x, y and z on the number line. X is to the left of y and y is to the left of z. Is y positive? And the statements are: statement 1, minus y is to the left of z. Distance between z and x is the same as the distance between z and minus y. Alright, pause the video, give it a try, and then let's do it together. Alright, let's do it together. Now, in the question stem, it's given that x is to the left of y and y is to the left of z. So let me plot x, y and z on the number line. Alright, so this is given. Now let's try statement 1 alone. Now it's mentioned that minus y is to the left of z. So what is one possibility? I could draw it like this, right? I have x, y, z and I have minus y over here. So this is clearly to the left of z. But is this the only possibility? I could also have it over here like this, right? Now remember, the purpose is to find whether y is positive or not. Now over here, if y is positive, then the number line should have it like this. Minus y should be to the left of y, right? Say y is 2, then minus 2 should be over here, right? Now if y is not positive, then you will have the scenario like this. Y would be over here and minus y would be over here. Say y is minus 3, right? So minus 3 is over here. Minus of minus 3 is 3. So it would be over here. So basically we need to find out from the information given which of these is true. Alright. Now using statement 1 alone, I have both scenarios possible. I have minus y over here and y over here. That's this one over here. And in this case, I have minus y over here and y over here. That's this case. So both is possible, right? So therefore, this information is not sufficient. So answer option A is ruled out. Let's move to statement 2 and try statement 2 alone. It's given that distance between z and x is the same as the distance between z and minus y. So what are the possibilities? Let's try that. I have x, y and z. One possibility could be x and minus y coincide, right? If they coincide, then the distance between x and z and minus y and z are the same. So this is one possibility. Is there any other possibility? Yes, there is one more possibility, right? Distance could be either in this direction or in this direction, right? So let's do it over here. So let me draw that over here. I have x, y and z, and minus y could be over here. So in this case also, I have both possibilities, right? Minus y is over here and y is over here, and y is over here and minus y is over here. Therefore, statement 2 alone is also not sufficient. Alright, now let's try statement 1 and statement 2 together. Let me make some space over here. Alright, so we are trying statement 1 and statement 2 together. Alright, so in this case, you can see that it's sufficient, and therefore the answer is option C. Why is that so? Why is it sufficient? You can see over here that as per statement 1, minus y has to be to the left of z, right? In this case, minus y is to the right of z. So this is ruled out, right? Therefore, we have only one possibility, which is this one over here, right? Therefore, we can see that minus y is over here and y is over here. Now, if this has to be true, we can easily find out whether y is positive. If y is 2, you have 2 and minus 2 over here. If you have minus 2 over here, then this would not be true, right? So we are clearly able to identify that y is positive, and that is why the answer to this question is option C. Now, some of you might think of, what about y being equal to 0? Now, if y is equal to 0, you can see that the distance between z and x and z and minus y cannot be equal, right? Because this is given in the question that x, y and z are in this order. Now, if the distance between z and x has to be equal to the distance between z and minus y, then definitely y cannot be 0, because if y is 0, then 0 and minus 0 would be at the same point. So minus y would be over here itself. And you can see that in that case, the distance between z and x cannot be equal to the distance between z and minus y. Let's do this question. X divided by y gives a quotient a and remainder b. B is not 0, alright, and it's given x greater than y greater than 0, and x and y are integers. The question is b greater than 2? So it's a yes or no question. Now, statement 1 says HCF of x and y is 3, and statement 2 says LCM of x and y is 36. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, I can say that x is equal to ay plus b, right? Because it's given, if you divide x by y, the quotient is a and remainder is b. And remember, it's given in the question that b is not equal to 0. Alright, now let's look into the statement 1. It's given that HCF of x and y is 3, right? That means 3 has to be a factor of x as well as y. Therefore, I can say that x is equal to 3m and y is equal to 3n, where m and n are any positive integers, right? Because it's mentioned that x and y is greater than 0. Alright, now using this, can I say whether b has to be greater than 2? Yes, I can say that, right? How is that so? Let's plug this in over here. I get 3m is equal to a into 3n plus b. So over here you have a multiple of 3. Over here you have a multiple of 3. Therefore, b also has to be a multiple of 3, right? Then only this equation will hold. Now, if b is a multiple of 3 or 0, right? 0 also it would hold, but it's given that b is not equal to 0 in the question. So therefore, b also has to be a multiple of 3, and therefore this equation, this information is sufficient. Statement 1 alone is sufficient. Alright, now let's take an example so that you understand this well. If you take x as 15 and say y as 12, right? You can see that b has to be equal to 3. Only then this is true, right? And this is a multiple of 3. Alright, now let's proceed to statement 2 here. That is, the LCM of x and y is 36. So I know 36 is equal to 9 into 4. So let's take a few sets of numbers which have 36 as the LCM. I could take 9 and 4 or 9 and 12, right? How do you get 9 and 12? I just multiply 4 with 3. So over here I have 2 3s, that's 3 square. And over here I have 2 2s, right? That's 2 square. And they don't have any common factor. So if I multiply 2 square with 3, still the LCM will be 36, right? So 9 and 12, if you have 9 and 12, if you take out 3, you will be left with 3 and 4. Again, 3 into 3 into 4, your LCM is 36. So it does not change. Alright, now let's proceed. I have 9 and 12. Just for practice, what would be some other set of numbers which have 36 as the LCM? I could again multiply 12 with one more 3, right? So 9 and 36 also have 36 as the LCM. Or I could multiply 9 with 2. So I get 18 and 4. Or I can multiply 9 with 4. In that case, I would get 36 and 4. All of these have 36 as the LCM. Alright, let's proceed. Now over here we have 9 and 4 and 9 and 12. Alright, now let's check whether this holds true whether b is greater than 2 in these cases. So over here 9 is equal to 4 into 2 plus 1. So in this case I'm getting a no. And over here 12 is equal to, so x is the greater value, right? It's given over here that x is the greater value. So 12 is equal to 9 into 1 plus 3. So in this case I'm having a yes. So I'm having a no over here, right? And I'm having a yes over here. So it's clearly not sufficient, right? So statement 2 alone is not sufficient, and therefore the correct answer to this question is option A. That is, statement 1 alone is sufficient, but statement 2 alone is not sufficient. Let's do this question. X and y are positive integers. Is the 7th root of x into y an integer? Now statement 1 says the 6th root of x is an integer, and statement 2 says y is equal to the 6th root of x. Alright, now pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now statement 1 says the 6th root of x is an integer. Alright, now is this sufficient to conclude whether the 7th root of x into y is an integer? It's not sufficient, right? What if I take x as 2 to the power 6? So 2 to the power 6, if you take the 6th root, you will get 2, right? So this is true. Now say I take y as 2. In this case, x into y is 2 to the power 7, and the 7th root of xy is an integer. So I'm getting a yes over here. Now if I take y as 3, then x into y would be 2 to the power 6 into 3. And if I take the 7th root of this is not an integer, right? Therefore, I'm getting a no over here. So in some cases, I'm getting yes, and in some cases, I'm getting no. Therefore, this statement alone is not sufficient. All right. Now let's proceed to statement 2. It's mentioned that y is equal to x to the power 1 by 6. All right. So let's multiply x and y. So x into y would be x into x to the power 1 by 6, right? Now that is nothing but x to the power 1 plus 1 by 6, right? And that is equal to x to the power 7 by 6. All right. Now let's take the 7th root of this. So the 7th root of x into y would be equal to the 7th root of x to the power 7 by 6, which is equal to x to the power 1 by 6. Now can you tell me whether this over here will be an integer or not? This will be an integer because it's given that y is equal to x to the power 1 by 6, and in the question it is mentioned that y is a positive integer. Therefore yes, the 7th root of x into y is an integer, and hence the answer to this question is option B. That is, statement 2 alone is sufficient, but statement 1 alone is not sufficient. Let's do this question. If x, y, z are integers, is x to the power 7 into y to the power 5 into z square positive? Alright, so we need to find out the sign of x to the power 7, y to the power 5 into z to the power 2. Alright, and you're given two statements. Statement 1 says x square into y to the power 4 into z cube is positive. Statement 2 says x cube into y square into z is positive. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now let's do it together. We need to find out whether this term over here is positive. Alright, so it's a yes or no question. Now this will depend on the sign of x and the sign of y, right? Remember, any positive number raised to either an even or an odd number gives you a positive value, right? But if you have a negative number and you're raising it to an even power, you get a positive value. For example, minus 2 square is equal to plus 4. But if you raise a negative number to an odd power, for example 3, minus 2 to the power 3 is minus 8. So you get negative. So negative power to the negative number to the even power gives you a positive number, and negative number to an odd power gives you a negative number. So that's the background of this question. So basically we need to find out the sign of x and y, right? Let's proceed. Statement 1 says x square into y to the power 4 into z cube is positive, right? So what all can we understand from this? One thing that we can understand is x, y and z are definitely not equal to 0, right? Because 0 is neither positive nor negative. All right. So none of them can be equal to 0. That's one inference that we can draw. And because this is positive, therefore z also definitely has to be positive, right? X square will definitely be positive. Y to the power 4 also will be positive because the powers are even, right? So z cube also has to be positive so that the product is positive, right? So from statement 1, we just understand that z is positive. But in this part, in the question, you can see that z has an even power. So it doesn't matter whether z is positive or negative, right? It will definitely be positive at the end, z square. So this does not give us any information about x and y. Therefore, statement 1 alone is not sufficient. All right, now let's see statement 2. It says that x cube into y square into z is positive. So what can we understand from statement 2 alone? Again, we can see that x, y and z is not equal to 0. All right. And because this is positive, either x and z has to be positive because y definitely will be positive, y square, right? Because it has an even power. So y square is definitely positive. So x cube and z either both have to be positive or both have to be negative. And that is also not sufficient because it does not give us information about y, right? We just, and again, we don't know whether x is positive or negative. Both is possible from these two different scenarios. All right. So 1 alone is not sufficient and 2 alone is not sufficient. Let's proceed and check whether statement 1 and 2 together is sufficient to solve this question. All right. So from statement 1, we know that z is positive, right? And from statement 2, z is either positive or negative. So when you combine these two, we can see that z is definitely positive. And when z is positive, x also is positive. So using statement 1 and 2 together, we know that z is positive and we know x is positive. But we don't know anything about y. So again, these two statements together combined don't give us enough information, right? Because x is positive, z is positive. Now, if you take y as a negative number, this number over here will be negative. If you take y as a positive number, this would be positive. So you are able to get yes and no. Therefore, statement 1 and 2 together is also not sufficient. And hence the correct answer to this question is option E. Let's do this question. X into y into z is not 0. All right. So that means x, y and z is not equal to 0. Now we need to check whether x by y divided by z is equal to y by z by x. All right. And statement 1 says y square is a prime number. Statement 2 says x into z is even. All right. Pause the video, give it a try, and then let's do it together. All right. We are back. I hope you have given it a try. Again, this is a yes or no question, right? Now, what is x divided by y divided by z? Let's simplify. All right. Remember, we had discussed this before. Whenever you can, first simplify. All right. So x by y divided by z is nothing but x divided by y into z, right? So we have simplified the left hand side to this term over here. Now, what about y divided by z by x? Y by z by x is equal to y into x by z, right? This x goes up, right? So you get y into x by z. So we have simplified the other term as yx by z. Now the question is asking us whether x by yz is equal to yx by z. All right. Now let's see. Even before we use the statements, is there anything else that we can derive from this? Let's take this to the left hand side. So we get x by yz minus yx by z to be equal to 0 if this holds, right? So let's make the denominator over here also yz. So this becomes x minus y square x by yz, and that has to be equal to 0, right? That's what's being asked. When will this be equal to 0? It will be equal to 0 when the numerator, that is x minus y square x, is equal to 0. And when will this be true? It will be true when x is equal to 0 or y square is equal to 1, right? How do you do that? Over here you can take out x. This becomes, the numerator becomes x into 1 minus y square, and this has to be 0, right? This will be 0 when either x is equal to 0 or y square is equal to 1. And x cannot be equal to 0 because it's given that x into y into z is not 0, right? That means x comma y comma z is not equal to 0. All right. So basically this equation over here will be true only when y square is equal to 1. Only then you can say that x by y divided by z is equal to y by z by x. Alright, now let's take statement 1. It says that y square is a prime number. Alright, is it sufficient to answer this question? Yes, it's sufficient, right? Why? It says that y square is prime. What's the smallest prime number? That's 2, right? The smallest prime number is 2. So y square is greater than 4, right? Therefore, you can definitely say that y square is not equal to 1. So if y square is not equal to 1, this is not true and we have a definite no as per statement 1. Therefore, this is sufficient, right? What about statement 2? Statement 2 says that x into z is even. It does not give us any information about y. So the critical information that we need to know is whether y square is equal to 1. So we don't know that. Therefore, statement 2 alone is not sufficient, and hence the answer to this question is option A. That is, statement 1 alone is sufficient, but statement 2 alone is not sufficient. Let's do this question. X and y are two integers such that 5 less than x less than y. Find x. Alright, and statement 1 says GCD of x and y is 5 and LCM of x and y is 50. That's statement 2. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, statement 1 says GCD of x and y is 5. That means 5 has to be a factor of x as well as y, right? Therefore, I can say that x is equal to 5a and y is equal to 5b, where a and b are integers such that the given criteria over here is satisfied. Alright, now I need to find the value of x. That's this question, right? So I need to get a numerical value, and getting a variable as 5a is not sufficient. So I'm not able to find this. Therefore, statement 1 alone is not sufficient. Alright, what about statement 2? Statement 2 alone. Let's try that. So we have LCM of x and y is 50. Let's just take a few numbers and plug them in. I could have x as 2 and y as 25, or x as 10 and y as 25, right? In both these cases, the LCM is 50. Alright. Now, in this case, you can see that x is equal to 2, and in this case, x is equal to 10. So I'm not getting a unique numerical value. Therefore, statement 2 alone is also not sufficient. Alright, now let's try statement 1 and 2 together. Now, let me tell you a trick over here. Whenever you have two numbers such that their LCM is something and their GCD is something, then the product of the two numbers will be equal to the product of the LCM and HCF. We can solve this question faster if you know this property. Alright, now I'll show you in a future video why this is true. In the next question, we'll discuss this. Alright, now over here, let's take this as a given and proceed. If you have two numbers and you know the LCM of the two numbers and the HCF of the two numbers, then the product of the two numbers will be equal to the product of the LCM and the HCF. Alright, so over here I have x as 5a and y as 5b. Alright, and I know that the LCM is 50 and HCF is 5. Alright, so let's proceed. So I have 5a into 5b is equal to 50 into 5. Therefore, I have a into b is equal to 10 on simplifying, right? Now, what are the possibilities over here? I could have a as 1 and b as 10, or a as 2 and b as 5, right? Because x and y are integers, so I cannot take fractions over here. Alright, now when a is equal to 1, then x will become 5 into 1, that is equal to 5. But over here, it's given that x has to be greater than 5, right? Therefore, this is not possible. So we just are left with one possibility, that is a and b have to be one among 2 and 5, right? So x would be equal to 5 into 2, which is equal to 10. That's x, and y is equal to 5 into and y is equal to 5 into 5, which is equal to 25, right? That's y. So using this, that is using statement 1 and 2 together, we are able to find the value of x. Therefore, the correct answer to this question is option C, right? And remember, we don't need to find the value of x because it was very easy to find it in this case. That's why I've just found the value of x as 2 into 5, which is 10. Alright, Now let's proceed to the next question, which is also a similar question. X and y are two positive integers. Find x into y. All right. Now statement 1 says GCD of x and y is 9, and statement 2 says LCM of x and y is 36. All right. Pause the video, give it a try, and then let's do it together. All right, we are back. I hope you have given it a try. Let's do it together. Now, over here, you can see that x and y are two positive integers and the GCD of x and y is 9. So using statement 1, I get that x is equal to 9a and y is equal to 9b, because 9 has to be a factor of x as well as y. Alright, now this statement alone is not enough to find x into y, right? Therefore, this statement is not sufficient. Alright, what about statement 2? It says that the LCM of x and y is 36. So let me plug in some numbers. I could have x as 36 and y as 1, or x as 9 and y as 4. You can see that in both these cases, the product is 36. Alright, so I cannot stop here, right? Remember, you have to try to disprove. You have to try to get a yes and no type of a scenario, right? So let's try to disprove with plugging in numbers. Is there any other possibility where the LCM is 36? I could have 9 and 12 also, right? If I have 9 and 12, the LCM is still 36. But in this case, you can see that x into y is not equal to 36, right? So 9 into 12 gives you 108. So you're getting two different values. So it's not a unique value, and hence statement 2 alone is also not sufficient. Alright, now let's try statement 1 and 2 together. Remember, when you have two numbers and you know the LCM and the HCF, the product of the two numbers will be equal to the product of the LCM and the HCF. So x into y in this case will be equal to 9 into 36, right? Therefore, the correct answer is option C. Remember, you don't need to do this multiplication and find the value of x into y. That would be a wastage of time. You just need to know that yes, statement 1 and 2 together will give me the value of xy. Alright, now let's also see in this video why the product of two numbers is equal to the product of the HCF and LCM of these two numbers. Now, for example, over here, I know that one number is 9a and the other number is 9b. Right, because the HCF or the GCD is equal to 9. Now, let's try to find out the LCM of these two numbers. So, I have 9a and 9b. I take out 9 and I'm left with a and b. So, a and b will not have any common factor because the highest common factor among 9a and 9b is equal to 9. Alright. Therefore, what would be the LCM of 9a and 9b? That would be 9 into a into b. Right, that's equal to the LCM. And it's given that the LCM is equal to 36. Alright, so over here you can see that a into b is equal to 36 by 9, which is equal to 4. So we have a into b is equal to 4. Now if you multiply the left hand side and the right hand side with 9 into 9, so you get 9a into 9b is equal to 9 into 9 into 4, right? And 9 into 4 over here is 36. So you can see that the product of the two numbers is equal to the HCF into the LCM. So this is the property that we have used over here. So if you know this property, you can do this even faster, this question. Let's do this question. Is a negative? Alright, statement 1 says a to the power 4 is a natural number, and statement 2 says a cube is non-positive. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, what are natural numbers? They are numbers like 1, 2, 3, 4, etc. Right? Remember, 0 is not a natural number and negative numbers are also not natural numbers. Now, if a to the power 4 is a natural number, then a can be either positive or negative. Right? Therefore, this statement alone is not sufficient. Let's take an example so that you deepen your understanding. If you take minus 2 to the power 4, that's equal to 16, right? So 16 is a natural number. Therefore, a can be minus 2. Similarly, 2 to the power 4 is also equal to 16. So a can be positive also. Now, a to the power 4 could be equal to 17 also, right? 17 is also a natural number. So a is not necessarily a natural number. So, but that's not what is asked in the question. All right. So we can see that a can be positive or negative. What about statement 2? it says that a cube is non-positive. Remember, non-positive and negative are not the same. Non-positive means it's 0 or negative. Alright, so a cube can be 0 or negative. So if a cube is 0, then a is equal to 0, and if a cube is negative, then a also is negative, right? Because negative to an odd power is equal to negative, right? So therefore statement 2 alone also we cannot say whether a is negative, because 0 is not negative. 0, remember, is neither positive nor negative. So statement 2 alone also does not give us a definite yes or a no, because in the case of 0 it's a no, and over here it is a yes. Alright, so let's combine statement 1 and 2 together. So over here a can be positive or negative, and as per statement 2 a can be 0 or negative. So when you combine these two together, a definitely has to be negative, because that's the overlap, right? 0 is here but 0 is not there over here, so this gets done away with, and over here you have positive, but as per statement 2 it can't be positive, so this is going away. Therefore statement 1 and 2 together is sufficient, and hence your answer is option C. Let's do this question. X and y are non-zero integers. Alright, is x to the power 2y not an integer? Alright, and statement 1 says y to the power x is a whole number. Statement 2 says y square is a whole number. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now what's the question? The question is whether x to the power 2y is not an integer. So it's the same thing as asking whether x to the power 2y is an integer, because over here we don't need to find the answer, right? The value, we just need to know a definite yes or a no. Alright, so it does not matter to us much whether it's a not over here or whether it's asking whether x to the power 2y is an integer. In either case, we will be just trying to find out yes or no. Alright, now in which case will x to the power 2y not be an integer? Over here we know that x and y are non-zero integers. Alright, so x to the power 2y will not be an integer when the power is negative, right? That is, if 2y is negative, then x to the power 2y will not be an integer, right? So why is that so? Let's take an example. 4 to the power minus 6. This is equal to 1 by 4 to the power 6, and therefore you can see that this is not an integer. So if you have the power as a negative value, then you don't get an integer over here. Alright, so this question is basically whether 2y is negative or not. So we have simplified the question. Alright, now let's use statement 1. It says that y to the power x is a whole number. Now remember, what are whole numbers? They are numbers like 0, 1, 2, etc. It starts with 0. Negative numbers are not whole numbers. Now y to the power x is a whole number. Alright, so what can we understand from that? If you take minus 2, y as minus 2 and x as 2, then minus 2 to the power 2 is 4. Similarly, 2 to the power 2 is also equal to 4. So y can be negative or y can be positive. So this is not sufficient, right? We are trying to find out whether y is negative. In this case, y is negative. In this case, y is not negative. So this is not sufficient for us, right? Therefore, statement 1 alone is not sufficient. What about statement 2 alone? It says that y square is a whole number. Again, whole numbers are numbers like 0, 1, 2, etc. Right? So if y square is a whole number, y can be either positive or a negative value, right? For example, if y is minus 2, then minus 2 square is equal to 4, right? The same thing that we have used over here. In this case, y is a negative value, right? And remember, 4 is a whole number. Similarly, 2 square is also equal to 4. So in this case, y is positive. So as per statement 2 also, y can be either positive or negative. It does not help, right? And combining statements 1 and 2 also does not give us extra information. Using both the statements together also, y can be positive or negative. So it is not sufficient, and hence the answer to this question is option E. Let's do this question. John has a box with blue and red balls. He found out that the ratio of red balls to blue balls is 4:1. Rita added some balls to the box. is the fraction of the balls that are red greater than what it was before. Alright, now statement 1 says more than half of the newly added balls were red, and statement 2 says the number of balls at the end is 8 by 5 the number of balls in the beginning. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now initially the ratio of red balls to blue balls is 4 by 1. So let the red balls be 4x and let the blue balls be x. So we have a total of 5x balls. Alright, now Rita added some balls to the box. Now let it be that she added A red balls and B minus A blue balls, so that the total of balls that Rita added is B. So initially there were 5x balls. Now Rita added B more balls, out of which A balls are red. Alright, now we need to find out whether the final ratio, that is the final fraction of the red balls, is greater than the initial fraction of the red balls. What was the initial fraction of the red balls? That is red balls by total number of balls, which is 4x by 5x, which is 4 by 5. Alright, now the final fraction will be 4x plus A, because you have 4x plus A red balls divided by 5x plus B, because that's the new total, right? Alright, so we have to find out whether 4x plus A divided by 5x plus B is greater than 4 by 5. That's what is asked in the question. So I have just added equal to and less than also, so that we understand a principle over here. Alright, which can be applied in the case the question mentioned equal to and less than as well. Alright, now over here the question is 4x plus A divided by 5x plus B greater than 4 by 5? Alright, now let's simplify this. Remember, whenever you can simplify, first simplify before you go to the two given statements. So by cross multiplying, we can simplify it. Alright, so we multiply the numerator 4x plus A with 5 and the denominator 5x plus B with 4. That is cross multiplication, right? So we get 20x plus 5A greater than, equal to, or less than 20x plus 4B. Alright, now you can see that on simplification, subtract 20x from both sides, you get 5A greater than 4B, right? Therefore A by B has to be greater than 4 by 5. So this is what is asked. So is A by B greater than 4 by 5? Remember, in this question we just have greater than. Whatever we are discussing is applicable even if the question had equal to and less than. So I'm just keeping it over here. Alright, so the question simplified is A by B greater than 4 by 5. And remember, what is A by B? A by B is the number of new red balls divided by the total number of new balls added. Alright, let's go to the statements. Statement 1 says more than half of the newly added balls were red. So this is not sufficient, right? Statement 1 alone is not sufficient. Why? Because we just know that it's more than half. That means A by B is greater than half, right? So A by B could be equal to 5 by 6, or it could be equal to 3 by 4, which both of these are greater than half, right? So if you have 3 by 4, which is greater, 3 by 5, 3 by 4, or 4 by 5, which is greater? You just cross multiply. You can see that over here you have 15 and 4 into 4 is 16. So this is greater. 4 by 5 is greater, right? So if A by B is equal to 3 by 4, then the fraction is not greater. The new fraction is not greater than 4 by 5. But if it is 5 by 6, which is greater, 5 by 6 or 4 by 5? When you cross multiply, you have 25 over here, and over here you have 6 into 4, that's 24. So this is greater. 5 by 6 is greater than 4 by 5. So in that case, the new fraction is greater. So you're getting a case of no when you have 3 by 4, and yes when you have A by B as 5 by 6. Therefore, clearly statement 1 alone is not sufficient. Alright. Now let's proceed. Let's see statement 2. Statement 2 says that the number of balls at the end is 8 by 5 the number of balls in the beginning. At the end you have 5x plus b balls, right? This is the total number of balls you have. So statement 2 says that 5x plus b is equal to 8 by 5 into 5x, which is the initial number of balls. All right. Now over here, you don't need to actually solve this equation. What will you get? You will get b in terms of x. B is equal to some constant into x. That's what you will get when you solve this, right? Remember, always try to reason out so that you reduce calculation as much as possible. You don't get anything about a from statement 2 alone, right? You just get b in terms of x, and that is not sufficient to determine whether a by b is greater than 4 by 5. All right. Now let's combine statement 1 and 2. If you combine statement 1 and 2 also, we don't get any extra information, right? Statement 1 says that a by b is greater than 1 by 2, and statement 2 gives us b in terms of x. Again, there is no additional information to derive whether a by b is greater than 4 by 5 when we use statement 1 and 2 together, right? Therefore, the correct answer to this question is option E, that is both statements together is not sufficient, and using both the statements we are not able to solve the given question.